computer science video with me, Mr Goff, for MrGoff.com. This video will focus on Ceaser and Vernam ciphers. Before we start talking about Ceaser and Vernam ciphers, let's quickly recap some important encryption terminology from GCSE. Plain text refers to the original message before it gets encrypted. Ciphertext is the message once it's been encrypted. Encryption is the process of converting a plaintext message to ciphertext. The Ceaser cipher is a very simple substitution cipher. Each letter in the alphabet is matched up with another a few letters on in the alphabet. Just like you can see here in this example grid, A is matched up with E, B with F, C with G, and so on. When we run out of letters, we wrap back round to the start of the alphabet. So W is A, X is B, Y is C, and Z is D. Using this grid to perform a Ceaser cipher shift, the plain text word bread becomes the ciphertext FVIEH. The Ceaser cipher is not at all secure because it can be cracked by trial and error in a maximum of 26 attempts. A Vernam cipher uses what is known as a one-time pad. A one-time pad is a truly random value that must be as long as the message to be encrypted. It's not always that easy to generate truly random values. One method that can be used is to take measurements of a lava lamp. Another is to use measurements of radioactive decay. Whatever you use, it must be used only once and destroyed after being used. The sender and receiver of the message must physically meet to exchange the key. The key is the one-time pad. A Vernam cipher sits at the opposite end of security to the Ceaser cipher in that it's thought to have perfect security. To use the Vernam cipher, a Boolean XOR operation is applied to the binary representation of the character in the text and the corresponding character in the key. So if the first character in the plain text was a capital E and the first one in the key was P, we would perform an XOR as you can see here. So that's where an exclusive OR is performed, so it's only if the numbers are 1 and 0 or 0 and 1 that we will have a 1. If they're 0 and 0 or 1 and 1, we will result in a 0. The resulting value for performing this particular XOR is the digit 5. If we took the digit 5 with its binary representation and we XOR'd it with the key again, we would be back to the plain text value capital E. The Vernam cipher has been proved to be mathematically secure. However, it's impractical for online communication due to the need for the sender and recipient to meet. Other ciphers use pseudo-random numbers generated by computers. All of these other ciphers, given enough time and computing power, could in theory be cracked. That brings us to the end of this video on Ceaser and Vernam ciphers. Join me in the next video when I'll be taking a look at dictionary-based compression methods. Use the resources at MrGoff.com to help you revise computer science, and until next time, it's bye for now.